Simplify 2a cubed c cubed times 3a squared c. So I'm going to rearrange everything and put the numbers first. So remember 2a means 2 times a. So all of these are multiplication, so it's commutative, which means we can switch them around. So 2 times 3. And then I'm going to have my a's, so times a cubed times a squared. And then I'm going to have my c's times c cubed times c. Now what I'm going to do before I start is I'm going to imagine that last c has an imaginary 1. Anything that has no power is actually to the power of 1. So then we've got 2 times 3 is 6. A cubed times a squared, well, when we multiply we add the powers, so that's a to the power of 5. And then c cubed times c to the power of 1 is c to the power of 4. The next one, simplify 10m to the power of 5 n to the power of 4 over 2m squared times n. So I'm going to do this like equivalent fractions, and I'm going to think what is common between the top and bottom. So let's work with the numbers first. So there's a 10 and a 2, so 2 goes into both, so I'm going to divide by 2. So on the top I'm going to have 5 m to the power of 5 n to the power of 4. 2 is going to become 1, so I'm just going to miss that out, m squared n, because obviously 1m squared is the same as n squared. Now I'm going to look at my m's, and remember when we're dividing by our powers we're taking away, so I'm going to divide by m squared because there's an m squared in both the top and bottom. So I'm going to divide by m squared, which means that it's going to be 5 take away 2, because m to the power of 5 divided by m to the power of 2, we take away the power, so that's going to be m to the power of 3. So I'm going to have 5m to the power of 3 n to the power of 4 over just n. And then the last step, I'm going to divide by that n on the bottom. So it's going to be 5m cubed, and then n to the power of 4 divided by n, again imaginary 1, so that's going to be n cubed. And that is my final answer.